Okay, we're going to look at page 364, number 17. So number 17 is a mass of 5 kilograms is suspended by two strings, 24 centimeters and 32 centimeters long, from 2 points that are 40 centimeters apart and the same level. Determine the tension in each of the strings. Okay, so I have it drawn out here that we have the diagram where the two strings are here, 24 centimeters and 32 centimeters. They are 40 centimeters apart, and here is a 5 kilogram mass. Now that mass is going to exert a force straight down. That force is Fg, we're going to call it, which equals mg, mass times g, which is 9.8, and that gives us 49 newtons. Okay, so the force down by that mass is 49 newtons. The mass is not moving. So because it's staying there, it's in equilibrium. And in order to be in equilibrium, there has to be an equal opposite force moving upwards. So the force is in the strings, and it's called tension. So you're going to have one tension going up this string, the 24 centimeter string, called T1, and another one going up the 32 centimeter string, called T2. And the sum of those two forces should equal 49 newtons up. Okay, so for them to be in equilibrium, we're going to draw this diagram here on the left. Okay, so this is all worked out. Here is the force going straight down, the 49 Newton force. Here is tension 1, and added to tension 2, these three vectors will produce equilibrium, so they should create a triangle. The angles here, theta and beta, I have marked up here on this, the first diagram. So theta is between the tension and the horizontal, so tension 1 and the horizontal. Beta is between tension 2 and the horizontal. And so when we look at these two tensions here in this diagram, we've created the triangle. There is a horizontal where they're connected. So there is theta. Okay. So theta, which is the same as that. And there is beta, which is the same as that. Okay. You could see that as if the tension was moving up that way. There's also beta. Okay, so that's where that is. Those two angles there make up this one contained angle in here between the two tensions. Okay. Also with tension 1, with the horizontal up here, that's beta. And with tension, sorry, that's tension 2. With tension 1 down here, that's theta. Again, the angle with the horizontal. Okay. So that would make this angle here 90 minus beta, if that's beta, because that's a 90-degree angle, and 90 minus theta here. Now, to figure out those angles, we're going to look at the diagram that is just with the lengths, okay, the string lengths and the ceiling length. So here's 24 centimeters, 32 centimeters, and 40 centimeters. The tension forces are going to go along the strings, so the angles are going to be the same. And here's how we figure them out. Okay, we've got all three sides of this triangle. So we're going to use the cosine law to figure out angle theta. Okay, so cosine theta equals 40 squared plus 24 squared minus 32 squared all over 2 times 40 times 24. Plug that in your calculator, cos inverse, and you get theta equal to 53.1 degrees. And to find beta, you could also use the cosine law again. Or I find it easier to use the sine law. So the sine law gives me sine beta over 24 equals sine 53.1 over 32. So that's using the angle that we found. and that gives me 36.9 degrees. Okay. Take those two angles and add them together to get the angle that we're looking for in here between the two tensions, and it ends up being 90 degrees, which is very convenient. Most cases probably will not end up being 90 degrees. These numbers just worked out so that, in fact, this triangle here is a Pythagorean triple, where this ends up being a right angle. So 40 squared equals 24 squared plus 32 squared. Okay, so that's very nice for this problem, but we're going to treat it as if it wasn't. Okay, so beta plus theta is 90 degrees. Now we can figure out the tensions. Okay, so using the sine law, well, we also actually have these angles in here. So 90 minus theta, so theta is 53.1. Okay, so 90 minus theta is going to be, let's write it in here, is 36.9. Okay, and then up here, 90 minus beta is going to be 53.1. Okay, so those are those angles once we know the beta and theta. So now we have all the angles in the triangle and one side. So we're going to use that and the sine law to figure out what the tensions are, the magnitudes of the tensions. So when I write the tension without the vector sign over top, it means magnitude. Okay, so tension 1 using the sine law gives me the tension 1 equal to 39.2 newtons. Okay, using the sine law again, tension 2 equals 29.4 newtons. Okay, and that allows us to sum this up with the tension in the 24 centimeter string is 39.2 newtons, and the tension in the 32 centimeter string is 29.4 newtons. And that's it for that problem. Remember, do math, not meth.